What is the time? Who can explain this so easily and briefly? Who can comprehend this in their thoughts so that they can put into the words and tell it? However, is there any other word that we are more familiar with, that we cognize immediately, than the word of this time that has clearly passed during our conversation? We really understand it right away, but when we say it ourselves, and when we hear someone else say it, then what's the time? I know that no one asks me, but I don't know when someone should ask and explain it to them. I started this video by quoting the famous philosopher Aurelius Augustinus, who lived from 354 to 413. Because when we ask the question of this time, we can't go too far beyond these lines. Really, please stop and think about it. When you ask yourself what is the time, you will find that you know the answer to this question, but you cannot put into the words. Throughout history, many philosophers, astronomers, clergymen, scientists have sought the answer to this question. Even many of us have stopped and thought about it from time to time. What is the time? When did it start? How did it start? Is it something that has existed since time immemorial and will flow away forever? Or does he also have a beginning and an end? In fact, even when we are asking the question, we are falling into a paradox. What do you mean? When did time start? So time is a phenomenon that exists in another time. Or it is just an illusion. If there were no matter, could we talk about time? What is not time? In fact, time is not the movement of planets or the clock. That is an object. Measuring time by the clock or counting the movement is not the time itself, but only the December that we measure. For example, when the Earth rotates one round on its axis, we say that a day has passed, and according to this universal acceptance, we have called this rotation 24 hours. Or when the Earth rotates a circle around the Sun, we also call it a year. If it weren't for these movements, which are almost certainly predictable, would be able to talk about time again. We can understand change only if we connect with something that has not changed. The Earth revolves around the Sun, but the Earth itself does not change. That is, we do not feel the rotation of the Earth. The same analogy applies over time. Time goes by, but we don't feel it. There has to be a succession of similarities, but succession isn't in the mind. Therefore, there can also be not the time for Augustinus without mind or intellect. For now, let's leave the answers to these philosophical questions at the end of the video, and look at this history a little bit when we first needed to measure time. From there, we will look at how modern science of today understands time, from Isaac Newton to Albert Einstein. What is the time? Physics defines time as the flow of the future from the past to present. Simply put, if a system does not change, it is timeless. In other words, it is infinite. Time can be considered as the fourth dimension of reality, which is used to describe events in three-dimensional space. It's not something we see, touch or taste, but we can measure its passage. When did we start measuring time? Since the past, mankind has tried to understand and calculate time by looking at the stars, the sun and the moon. At first, it was enough for people to know only the time of rain, snow, cold, and heat. The season governed people's lives and told them time to harvest, the time of migration, the time of shelter. Minutes and seconds are the product of more contemporary eras. But people tried to divide the day into several parts and needed more and more smaller time zones. The date of the smaller time units is parallel to calendar. The Sumerians, who first divided the year into units, were also the first to divide the day and began to calculate the time. These efforts, which continued with the Egyptians, developed roughly with the Greeks and Romans. How did we start measuring time? Ancient civilization developed calendars to keep in mind large time periods such as days, months, and years. The first time measuring instruments were used by the ancient Egyptians. During the day, they used simple sundials. The sundial consisted of two pieces of wood, one with a dial indicating the time, and the other casting a shadow on it. The Egyptians measured time not only by this, but also by observing the position of the stars in the night sky. Besides, They were the ones who used the first water clock again. Operation of water clocks. It was provided by transferring water from one container to another. Inside the container at the bottom was a scale that showed the time that had passed as the water flowed. Sun and water clocks were later also used in Greece, Rome, and Europe. These were two of the three time measuring instruments used in the early years of the Middle Ages. Third was the hourglass, which measures the passage of time with sun flowing between two glass tubes. The first mechanical watches are 13th. It was made in the last period of the 13th century. These were watches made with the intention of general use. They were placed in churches, squares, or other public places that many people could see. Small home watches and pocket watches 16th. It was developed in the 16th century. Inexpensive factory-made wristwatches than anyone can have 20th. It appeared at the beginning of the 20th century. The first time it became important to measure time on a universal basis and seriously was 19th century begins with train journeys. At that time, the towns adjusted their clocks according to a certain time of day by themselves. But this time, they said was only valid locally. So if the sun is right on top in a town, it is noon there. As they say today, it is like 12 o'clock. But you can't say that it is 12 o'clock there either, because the sun won't be right on top in another town at the same time. That's when people started traveling with train travel, and this started to be a problem, because the departure time of the trains was determined by the time they started moving. For example, if there was a train going from Manchester to London, there would be constant confusion due to difference measuring the time of people living in London, as this train would depart according to where it was moving, that is, according to Manchester. Imagine that this problem is growing even more with trains departing from different stations in different provinces around the country. That is why a system was needed that would make the clocks in remote places compatible with each other. So far we have talked about how we started measuring time and why we need to measure it. But, as I said at the beginning of the video, the development of all these systems did not give an answer to the question of the time really is. Was time something that exists physically, or was it something that only exists in our minds? In order to measure time, we need a time point. That is, the occurrence of an event. For a time, there must be two events. Thanks to this, a regular sequence of events or changes can be used like a clock. We can measure time by the oscillations of a pendulum, an hourglass, a simple sundial showing the change of shade, or by the vibration of a cesium atom. All this indicates that there is an inextricable link and time. But if time is fundamentally connected with motion, is it absolute, or does it depend on the speed of the observer? According to Newton, he thought that the same time between two events could be measured decisively. Normally he measured it. Provided that a good watch was used, the same result could be achieved. Newton's absolute time is very much in line with the everyday time we are used to. According to Newton, time is, first of all, something that flows forward non-stop. You can't go back in time and take your date of a bird a little forward or backward, for example. Secondly, it is an absolute thing, something that does not change for everyone and for every moving object. In other words, in Newtonian theory, time is universal. Everyone is growing up and getting older at almost the same time. But today we know that this is not really the case. According to Einstein, 20th at the turn of the century, a man who was going to challenge Newton, the most important scientist in history, published an interesting article. Einstein, thanks to this, it became clear that both the concepts of space and time are relative. Einstein provided this with special and general relativity. According to the theory of special relativity, time flows differently observers at different speeds. In general relativity, the gravitational force bends space-time. Change time causes it flow fast or slow, and space cannot be bent without time. From this we understand that the change of time depends on two factors. The first is motion, and the second is the force of gravity. If start moving, time will start flowing differently for me than for any other reference point. Or, for example, if I go near a black hole, its gravity will increase so much that now time will flow differently for me than for a person on Earth. The most important scientist who had an impact on our understanding of time is undoubtedly Albert Einstein. According to Einstein's equations, time expands as an object approaches the speed of light. So, time flows more slowly for a moving person. Before Einstein, no one even thought that such a thing would happen. So why don't we see this effect on our daily lives? Because the effect of movement at slow speeds on Earth on time is so small that we cannot perceive it. In an experiment conducted in 1971, the effect of motion on time was proved extensively in Einstein predicted. Two atomic clocks have started working so that one is on the ground and the other is inside a jet plane. When the experiment was completed, the atomic clock on the plane was several billionths of a second slower than the atomic clock on the ground. Of course, this speed was very low compared to the speed of light. But indeed, if we could reach speeds close to the speed of light, time would slow down much more, as Einstein discovered. With this experiment, we realized that in motion represented space and time could not be considered separately from each other. And that's exactly what Einstein wanted to tell us. Space and time were united. According to Newton, the acceleration was a mysterious attraction of mass between two bodies. The gravitational force of large bodies was greater than that of small ones. Einstein refuted this idea, showing that the gravitational force is the same thing as acceleration, the principle of equivalence. For example, imagine that you are inside a rocket going full throttle in outer space. Because the rocket is constantly gaining momentum, you cling to your seat and are exposed to gravity as if you were standing on the same earth. That is why, according to Einstein, gravity was not a mysterious force between, it was a space-time warp formed to the presence of mass. In addition, within the gravitational field, time should have flowed at different speeds for observers at different heights. The stronger the rate of gravity, the greater the effect on time. That is, time flowed more slowly when gravity was strong. This thesis was experimented within 1962 with very sensitive clocks placed at the top and bottom of a water tower. It was observed that the clock, placed at the bottom of the tower, that is, closer to the Earth, works more slowly. This is what general relativity predicted. In the Newtonian universe, objects move, forces attract and repel each other. But time and space were just going on and on without being affected by them at all. It was thought that space and time would last forever. In the theory of general relativity, space and time are now dynamic. Space and time are not only affected by everything that happens in the universe, they also affect everything that happens. Without the concepts of space and time, we cannot talk about the events taking place in the universe. This understanding of space-time, which came with Einstein, led to fundamental changes in our thoughts about the universe. In fact, the concept of an unchanging universe that has always existed and will continue to exist forever has been replaced by the concept of a dynamic, expanding universe that began at a finite time in the past and will end at a finite time in the future. This meant that time also had a beginning and an end. Einstein's theory indeed confirms that time is woven into the fabric of the universe. But there is a big problem that he cannot fully solve. Why can we go in any direction in space while we can only go in one direction in time? For example, I can go back and forth, right and left, up and down, as I want in space. I can get up from here and go to London and then go back to Manchester. But why can't I do this at time? While it is theoretically possible, no matter what we do, the past is always stubbornly behind us. It's called the arrow of time. When a drop of paint drops into a glass of water, we instinctively know that the paint will fill the glass. But we don't even think there's any chance we will see the opposite. In physics, this is defined as the second law of thermodynamics. Accordingly, system occur universes or entropy over time. The systems in our universe are moving from order to order, and this is a feature of the universe that defines the direction of the time arrow. When we go back to early days of the universe, it has to look at not only different but also more regular than it is now. We don't know why entropy was low before, but at least we know that there is a point at which the universe begins and entropy is low. So the Big Bang is what caused the arrow of time to move in one direction. We can also think of it as an established watch. Just as the energy of a firmly established clock is draining away as time progresses. The universe has been draining its energy since the Big Bang and is becoming increasingly disordered. But doesn't it mean that if time has a beginning and disorder is constantly increasing, it will also have an end? As a result, if we are not aware of any change, we cannot be aware of the time either. The movements of the Earth and the Moon play an important role in our perception of time. If you were waiting in a wide, empty and endless room, you would be quite unsuccessful in estimating how much time has passed. Time is relative, not absolute, as modern science shows us today. Motion and gravity can bend it. In addition, time is one with the universe. We all fall into the following mistake. Time has always existed before the universe, and was constantly flowing from the past to the future. Time also occurred with the Big Bang, as did space. That is, the universe did not exist in time. It coexisted with time.